Florence Parker-Jurd from the University of Plymouth with us today, which is really exciting. She will be talking about microplastics and her work in the university, and also the work that we're collaborating on under Preventing Plastic Pollution, which is a EU Interreg project and has 18 different partners across England and France. We'll be working in the Tamar for this, and I'll be talking a little bit at the end of the presentation about how you guys can get involved if you're around the Tamar, or even if you're not, how you can help us clean up in that area. So without further ado, I'll pass over to Flo.
Hi everyone. So yeah, I'm Flo. I work as a research assistant in the marine litter team at the University of Plymouth, where I did both my undergraduate and my postgraduate degrees, and then I was lucky enough to be employed following my masters. I was planning on just giving a quick roundup of our research group, what we do and the current projects we've got going on, before talking a little bit about some of the work we did for DEFRA a couple of years ago, looking at the tyre wear particles as contributors to microplastics, and then briefly talk about the project that I'm working on at the moment with Westcountry Rivers Trust. So you can change to the next one, Lydia. Oh, next slide, Lydia, please.
Oh, has it not gone through? Hang on.
Oh, there we go. So I'm sure everyone in this meeting is already aware that plastic contamination is a huge global problem. It contaminates terrestrial and marine habitats from the poles to the equator, from the sea surface to the deep sea. But it presents not only an ecological problem, but also a social and economic one. So the economic value of the environment is dictated by its quality, which allows for a diverse range of activities: fishing, recreation, research, tourism. Litter can reduce environmental value and therefore the economic benefit, and it can also increase costs associated with maintenance. The presence of litter on places like beaches has also been shown to reduce well-being associated with visiting places such as beauty spots. That said, plastic is an extremely useful material. It's very cheap, it's very versatile, and in itself isn't necessarily the issue. It's sort of become a victim of its own success in some ways, and it's the manner in which it's used in most cases, which is the root of the issues, and there's often not much consideration at the design stage for end of life. So if you couple that with a single-use throwaway ethos and poor irresponsible disposal, that's normally the root of the problem. So our research group, which is led by Richard Thompson, is at the forefront of marine litter research and has helped guide industry and provide evidence for governments and international organisations. So, for example, someone in our team did a piece of work a few years ago which directly led to a policy change on the ban of microbead use in cosmetics in the UK, and I think other countries are either planning to or have followed suit on that. So Richard coined the term microplastics back in 2004 and has since produced some of the first papers on topics such as ingestion and retention of microplastics in organisms and commercially important fish species, accumulation of microplastics in remote and isolated environments such as the Arctic and the deep sea, microbeads in cosmetics, and the release of microfibers from textiles during laundering. So our team is made up of a couple of academics, a number of research fellows and research assistants, PhD researchers and student interns. And it's slightly unique in that quite a number of our team are actually environmental psychologists. So they'll look to understand the relationship between people and the marine environment. So we all know marine litter is a huge issue, but unless you understand how people are willing to change their perceptions and their behaviours, you're not going to have the desired impact. So Lydia, you can change on to the next one. So we've got a number of projects that are currently funded. I'll just quickly give you the lowdown on each of them. So the concept of the Minimise project is to generate novel data on how plastic particles interact with living tissues and distribute themselves through the food web, and how this can affect ecological processes. So this project looks to support the development and design of safer plastic alternatives. The rationale for Limnoplast is that while there's much motivation to solve the microplastic issue, most of our efforts are focused on marine environments. However, there's huge emerging research to show that freshwater ecosystems are also highly sensitive to microplastic pollution, and also they serve as the pathway to the marine environment. So Limnoplast is one of the projects that's led by psychologists, and it takes a holistic approach and challenges barriers between different disciplines and sectors. So it combines environmental, technical and social sciences, and notably it will transfer all its project outcomes directly to European decision makers. Bioplastic risk is due to start in March. The rationale for this work is that biodegradable packaging is increasing and products are increasingly looked at as solutions to the global plastic crisis, yet there's very, very little data on their fate and impact in the environment. So in collaboration with Bath University, Plymouth Marine Laboratory and Plymouth Marine Laboratory, University of Plymouth will be looking to develop an understanding of how biodegradable materials react upon their entry to the marine environment and how their characteristics can be tailored to minimise any potential risks. So it will also look into the effects of any chemicals that are added during manufacturing and how they may affect the wider ecosystem and whether certain parts of the environment are more at risk than others. So if you had a generic plastic bag compared to one that suddenly breaks down to thousands of little pieces that are also potentially dangerous upon the environment, that's probably no better than just the original plastic bag. So Expedition is quite an exciting project. It's an all-female sailing voyage circumnavigating the globe via 4 ocean gyres, which are large swathes of open oceans that accumulate floating litter. So University of Plymouth are leading the science programme, but this project's obviously not very COVID friendly, so it's on pause at the moment, although I think the boat was stuck in Tahiti when everything shut down, so there are definitely worse places for the crew to be stuck. So tyre loss, this leads on from a pilot study we did for DEFRA a couple of years ago, which I'll come on to in a moment. But I'll report evidence the transfer of tyre wear particles to the marine environment, but their fate and distribution and the impact they have still remains something of a mystery. So with Exeter Uni, Newcastle University and Plymouth Marine Laboratory, this project will aim to understand how far tyre wear can spread and any harm they might cause by quantifying tyre wear in sediment, the water column and biota with increasing distance from the coast. And then lastly, PPP, which I'll also come on to in a minute. So this currently funds my position. It's funded by Interreg and I'm working very closely with Lydia, Holly and Andy from Westcountry Rivers Trust on this one. Its main goal is to develop a transferable tool to identify key sources, pathways and places of accumulation of litter in coastal river catchments. It's also worth mentioning that we have scope for any businesses or industry figures to come directly to us with more tailored questions. So in the past, we've had companies who want us to aid development of a washing machine filter to help mitigate textile emissions, which we have a lab full of domestic washing machines we can use to test different devices. We've done reports on development of beach cleaning apps and also on advising the design of an ocean cleanup vessel, so it's very varied. And there's more about all of these on our Marine Litter Team website. Okay, you can go on to the next one. So I'll just quickly talk about the project we did 2018 to 2019 for DEFRA looking at tyre wear particles. So the basis for this study that there was a number of desk-based reports coming out in kind of mid-2010 suggesting tyre wear to be a substantial contributor to microplastic emissions. Yet these weren't supported by any empirical field data. They're based, for example, on weighing a car tyre at the beginning and the end of its life and then multiplying that up by the number of vehicles on the road. So while there's evidence to suggest they're generated in vast quantities at their source, which you can see for yourself, so often when you go for an MOT, you'll get an advisory or you get advised that your tyre is changing because the tread is worn too thin. But it's not understood how these particles are distributed in the environment. So we wanted to generate some field data on emissions of tyre wear directly as they pass to the marine environment to either confirm or dispute these desk-based reports. And in each instance, we also looked at emissions of a known prolific microplastic polluter, so in this case microfibers, in order to have some understanding of the relative importance of tyre wear. So tyre wear particles are generated due to friction at the tyre rod interface, so it's a bit like when you have grubby hands and you rub them together and you get these little tiny sausage-shaped particles with tapered ends. As you can see in this picture on the right, there's a picture of some tyre wear particles. They're typically between 4 and 350 microns, which is equivalent to 0.004 to 0.35 millimeters, so really tiny. You can go on to the next one, Lydia. So our approach was to quantify tyre wear in the 3 theorised major pathways to marine environment, which was treated wastewater effluent, untreated stormwater runoff and deposition from the atmosphere. tire particles are quite complex to process and analyse compared to more conventional microplastics, and they don't respond well to the techniques we'd normally use. So we often add our samples to very dense solutions and hope that the plastics float and they're separated from the environmental matrix they're in. And then we'd couple that with running them through an instrument called an FTIR, which generates lots of peaks, and you have different peaks as signature of different types of polymers. So you can say, is this particle natural or synthetic? And if it's synthetic, which polymer is it? So here we, with the help of Newcastle University, we used a bulk chemical analysis, and we quantified a unique component of tyre wear and then related that to the proportion this component normally makes in tyre tread in order to have an idea of mass of tyre wear being emitted. That meant obviously we had fibres counted in mass and tyres counted in abundance. So in order to compare these two emissions, we had to do this qualitatively. We replicated this study in Bristol as well in order to provide more generality to the results. And I think if you click, Lydia, you can see a picture of us out in the field collecting some lovely sewage samples. So some of our key results, we found tyre wear in every single pathway we examined. It was present in the vast majority of the surface water and atmospheric samples, and we looked at in the atmosphere beside motorways, rural roads and in urban environments, but only in 50% of wastewater samples, suggesting the treatment system has some capacity to remove tyre wear as it does other microplastics. Like the issue of comparing tyres with fibres, it's quite hard to compare these different pathways because some have intermittent discharge and some are discharging continuously. But on balance, we found that surface runoff was the most substantial pathway, despite the fact it only is discharging particles during rainfall events. So we concluded generally that the desk-based estimates are probably correct and that tyre particles are large contributors to microplastic emissions. An interesting finding just from the fibre data alone was that the atmosphere appeared the largest pathway for fibres. So this suggests that all the efforts going into mitigating fibre emissions in washing machines are only tackling half the issue. Plus those laundry effluent is going to pass directly into wastewater treatment, and we know that wastewater treatment is actually highly effective at removing fibres. So actually more effort should go into focusing on understanding what permutations of textile design influence shedding, because that will mitigate emissions via both pathways. So again, you need better thought at the design stage for end of life. And then I think if Lydia clicks, you can just see a screenshot of the report if anyone's interested. Okay, and you can go on to the next one. So we did some very rudimentary settling experiments in our labs, which indicated that tyre particles at the smallest end of the spectrum, which notably are more abundant, have the capacity, once expelled to the marine environment, to stay floating at the water surface, so potentially with the potential to be transported longer range, whereas the larger particles, which make up more of the mass but less of the abundance, likely settle close to their point of emission. So to better understand their fate and distribution, future work should look to conduct sampling in the marine environment with increasing distance from their point of emission, and potentially also in remote or isolated environments. I think also to sample greater distances from roadsides to understand the potential for long-range transport via the atmosphere. Also sampling a greater diversity of weather conditions, so rainfall could increase transportation and runoff, but also hinder generation due to reducing friction between the tyre and the road. Notably also it should sample in a greater number of catchments, because then you can draw conclusions on a wider scale, maybe nationally, which have greater evidence for policy change, and also consider both the toxicity of the particles and their leachate. And hopefully these are things that will be addressed in the 3-year tyre loss project I mentioned earlier, which started in the new year. So obviously tackling tyre wear is quite a complex issue. They're not a dispensable product like microbeads in cosmetics are, which have an easily exchangeable natural counterpart, and to add to that, friction is very necessary for their function, and tyres are already hugely regulated and the tyre industry will not compromise safety at the expense of wear. But on an individual scale, there are a couple of things you can do. You can ensure correct tyre pressure, avoid aggressive driving, so braking, accelerating, cornering, avoid unnecessary travel. The use of electric cars could make driving smoother, but also increase wear due to increased weight. So that one's a bit up for debate. Okay, you can change to the next one, Lydia. So since spring last year, I've been working with Westcountry Rivers Trust, among many other organisations, and locally also includes the Environment Agency and Plymouth City Council. And this is on preventing plastic pollution, or PPP. You're probably already aware of the project, but if not, in a nutshell, some of its major objectives are to develop a tool to identify key sources and accumulation hotspots of litter in coastal river catchments, and evaluate physical and behavioural tools to intercept and mitigate this waste from a sustainable and ecological perspective. And it's being developed across 7 catchments, 3 in France and 4 in the UK, one of which is the Tamar catchment, with the aim that after the project's ended, this tool will be transferable to areas outside of the study area. And you can see Holly, Lydia and I out in the howling wind and rain on Dartmoor collecting some microplastic samples there. You can change on to the next one. So the University of Plymouth will contribute to PPP from 2 aspects, environmentally and socially. So my role will be focused on the environmental side, so I'll be spending my time monitoring the extent and composition of micro and macro plastic pollution in the Tamar. If you click again, you can see an image of the kind of process we use to sort our microplastic samples. So we'd sieve each sample, digest each one twice in 2 different solvents in a heated shaking water bath, then vacuum filtrate each sample, and then count and characterise every particle I deem to be microplastic and note all its characteristics such as shape and colour, and then run it through the instrument I mentioned earlier, the FTIR, to determine if it's natural or if it's synthetic, and if it's synthetic, which polymer it is. So it's quite a lengthy process. And then we'll use this baseline database we create to trial the sustainability and suitability of physical interventions to plastic waste. So one thing we're doing is looking at the cost effectiveness of a sea bin, which is a floating bin which is mounted to pontoons in harbours and marinas, and it has a vacuum which is designed to capture waste floating at the surface, so things like crisp packets and drinks bottles. And then my colleagues Deb and Sophie, they'll be focusing on the social and behavioural aspects of the project, and they'll provide valuable insights on how to achieve transformative change in plastic use and management across sectors including business and retail, tourism and education. And they'll work together with all the other organisations on the project to evaluate the impact of various behaviour change interventions designed to reduce plastic consumption and improving recycling practices. So, for example, they'll look at how signage on general waste and recycling bins impacts people's waste disposal practices. So I think that's about it from me. I'll hand back to Lydia, but thanks very much.
Cheers, Flo. Sorry, I've got a bit of feedback. Hang on, Flo. Do you want to mute yourself?
Oh, yeah.
So we'll take questions for Flo after I've done a little bit about how you guys can get involved. So preventing plastic pollution, as Flo mentioned, is based in the Tamar catchment, and we'd love you guys to get involved. So there's various different ways. So Westcountry Rivers Trust will be working to hopefully do some cleanup events this year if and when restrictions ease. So we've not put set dates in the diary due to uncertainty, but please do keep an eye on our website. We've got a Preventing Plastic Pollution page on the main Westcountry Rivers Trust website, so check it out, and we'll be releasing dates for that, and I'll make sure that the CSI community has those dates when they're released. And as we go into the summer, you know, if you're a group and you're interested in organising your own clean in the Tamar catchment, then please do let me know. We have guidance and survey forms, and we've got an online database that the Rivers Trust have developed, which you can enter all your data onto, and that will help with us with our mapping. So we've mapped out hotspots in the Tamar, and that will help validate that mapping. And then we're hoping to produce a model that can be transferred to different catchments once we've finished the project. And then also what you can do probably at the moment is let us know about any hotspots in the Tamar area. So, you know, if you're out walking on your daily walk and you notice large accumulations of plastic, in particular if they're accessible, then in the summer we can get, you know, groups of people down there and communities down there to clean it up. So that'd be really useful to let us know of any areas that you know of. So what I'll do is just open up the discussion. I think we've got one question already. So from Mark, Could you provide some information on microplastics in biosolids, please?
Oh, I'm really sorry, that's not my area of expertise. Are you worried about contamination in, if you bought biosolids? Is Mark there to clarify?
Are you able to unmute yourself, Mark?
Hello, can you hear me?
Yeah, we can hear you, Mark. Hi.
Yeah, hi. Sorry, I know it's not related to tyres, but it is related to microplastics. There's been some reports in recent times about the concern of microplastics coming from sewage works and then being spread on the land, potentially causing lots of problems with soil microorganisms and long-term contamination. And I think it's just not widely known about, and it could be causing real long-term problems. I just wonder if you had any comments on it.
Yeah, no, certainly. So wastewater treatment companies get a lot of stick for emissions, and actually, as I mentioned, they're very, very effective at removing fibres. I think it's over 90%, but you're right, if that then just gets put into biosolids, which is then spread on land, as soon as it rains, they could all easily wash into waterways and then from the rivers into the sea. It's certainly something I think the microplastic community is aware of. I don't know if there've been that many studies on microplastics in biosolids. Yeah, I don't know what the solution to that would be, because there's not much way of removing the plastics from the biosolids itself. It'd be a hugely lengthy, expensive, energy expensive as well process. So I don't know what the answer to that one is.
John says that would reed beds be a sensible way of filtering road runoff, or as these beds are populated by microorganisms, would this simply reduce the particles into the base of the food chain? I don't know if you have comment on that, Flo.
Yeah, I think that's something they're increasingly looking for in road runoff treatment. It's quite space intensive, but less energy intensive. So I think they've just built one in Plymouth, actually, in Forder Valley. They're building one. I don't know personally how effective they are, but I'd say people are moving towards that increasingly more so at the moment. The alternative, I guess, is to put in quite large hard infrastructure such as oil separators, which sit below the road, and they're meant to separate not only solids, but also things like hydrocarbons and oils. So they'll use density separation to remove particles and oils that way.
Mr. T's got your hand up, Ian?
Yeah, thanks, Eddie. Yeah, Flo, thank you very much. Extremely interesting presentation. Couple of thoughts really about slightly more, perhaps more insidious effects of tyre particles. Has much work been done on looking at the fact that there are a lot of additives in rubber, like plasticizers, things like that, and things from vulcanizing rubber? Is there has much been done to look at them potentially leaching out once they've entered, say, filter feeders in the environment, that sort of thing? And then also, I would imagine rubber's got the capability, once it's out in the environment, to actually concentrate up trace pollutants, and that they could then be transported into the food chain. Has much been done on that, do you know?
Yes, there's very, very few toxicity studies on tyre particles. So it's one of the things they're looking at in this new tyre project at the university. Of the couple there have been, there's quite an emphasis that it's not only the particle you need to consider, it is the leachate as well, because as you mentioned, compared to other microplastics we're worried about, there's a whole host of horrible chemicals that are in tyre tread. In terms of leaching, I don't know. So other microplastics can also, once they're not necessarily in an organism, but once in the seawater, they can adsorb lots of chemicals present in the seawater which stick to the surface, and then once ingested, because they're in a warmer environment, can leach into the bloodstream. I don't know if that's possible with tyre particles. I'm afraid there's just not enough out there on it yet. But I would have thought it was a worse scenario than a fibre, for example, just because of the things they already contain.
Yeah, I think you're probably right. Yeah. Thank you very much.
Okay, so has anyone else got any other questions for Flo? No? Okay, well, you're welcome to, oh, yes, just saying thank you for the presentation, Flo. There's a few nice comments in the chat if you want to have a look. But yeah, so thank you everyone for joining us. If you do have any further questions, you can contact Flo or myself. Obviously, you all have the CSI email address, so you can use that to let us know if you have. Oh, we do have one more question. Sorry, Flo. Has rubber tyres got any actual rubber in it?
Is that natural rubber or synthetic?
Or, she just says got any actual rubber in it. I don't know whether she means.
If you mean natural, I think passenger tyres are normally a combination of a mixture of natural rubber and then styrene butadiene, which is synthetic rubber. I think truck tyres differ slightly in their composition, but I think most generic passenger tyres are a mixture of the two.
Okay, brilliant, thank you. And yeah, she says thank you for that. So thank you, Ellen. Yeah, so do let us know if you have any other questions you think of post presentation. But have a lovely day, everybody. I hope it's not as windy as wild as it is here in North Cornwall. But yeah, we'll have another webinar in February, which in fact will be by Ian Townsend, Mr. T, so that'd be great. And in the meantime, stay safe everyone and stay well, and we'll see you soon. Bye bye.
Thanks, Lydia.